Electric potential. See, electric field produced by a charge can be represented in two ways. First is by intensity of electric field, which is a vector quantity. Then second by electric potential, that is a scalar quantity. Now let us start with the electric potential. For this, consider a source charge plus Q placed at point O and a small test charge, by default we take it as a positive test charge, is placed at this point, and due to the positive test charge it will experience a repulsive force as shown. Now we have to bring this test charge from one point to another point. Let us bring this test charge from point B to point A. That is, we need to calculate the potential difference between point A and B. So potential difference between A and B will be termed as work done in bringing the charge from one point to another point, that is W upon Q naught. So from here we can define what is potential difference between the 2 points. It is the work done in carrying a unit positive test charge from one point to another in an electric field. We can also define the SI unit of potential. SI unit of potential, as from the formula we can write down work done is represented in terms of joules and charge is represented in terms of coulomb. So SI unit of potential is volt. 1 volt is equal to 1 joule per coulomb. If we consider one of the point B to be placed at a very far off distance, that is at infinity, that means at infinity, B is at infinity, then the potential at B, as it is a far off distance, due to charge plus Q, it will be nearly 0. So we can write down the above formula like this, or simply work done upon Q. That will be the formula for the electric potential. So what is electric potential? Electric potential at a point in an electric field is the work done in carrying a unit positive charge from infinity to that point. Now let us understand potential difference and potential due to a point charge. Potential difference and potential due to a point charge. For this, let us consider a source charge placed at O plus Q and a test charge Q naught at some position A. We have to bring this test charge from position A to position B. As it is a positive test charge, it will experience a repulsive force as shown. Now let us designate the distance between the source charge and the test charge. As it is placed at O, let the distance be represented as RA. And the distance of the source charge to the final position, that is the B position, let it represent as RB. At any instant, let this test charge in its motion from A to B reaches to point C. The distance of this point C from O, let it be represented as R. Alright. Now, at any instant during its motion, when it reaches from A to C, the force experienced on the test charge will be Q naught E. Also by Coulomb's law, we are aware force will be this 1 upon 4 pi epsilon naught Q naught upon R square. This is by Coulomb's law. Now further, this test charge Q naught is brought in from position C to position D. That is, on its motion of the test charge from A to B, we have considered an instant at which the test charge is at C. At C, we have calculated the force. Now this test charge, when it is at C, it is further moved inwards towards B to a small distance. Let this distance be represented as small distance, so it is represented as dr. This dr is a small distance, that is, it is tending to 0. Now the work done in bringing the charge from C to D will be represented as the external force into the distance, that is dr. Or we can see that the distance is towards B and force is repulsive, which is in the outward direction. Both the directions are opposite, so we can place a sign of minus, that is F into dr. That will be the work done. Now the force, we can put down the value from the Coulomb's law, that is 1 upon 4 pi epsilon naught q naught upon r square into dr. Now the work done to move this test charge from A to B can be written as, when we will integrate this small distance to cover the complete distance between AB, that is from RA to RB, we have to integrate it. When we will integrate, we will find these terms are constant. Only 1 upon r square will be inside the integral sign. And after integrating, we will get this. Putting down the limits, we will get one upon RB minus 1 upon RA. But the potential difference between the points A and B can be represented from our earlier formula, that is VB minus VA into charge Q naught can be written as Q naught upon 1 upon RB minus 1 upon RB. I have simply put down the value of the work done AB. Now see what will happen. We are left with potential difference between the 2 points. Now if we consider that the point A is at infinity, that means we are considering point A is at a very far off distance, then what will be the distance RA? RA will be considered to be infinity, that is very far off distance. We will put this infinite value here and we will achieve this term as 0. And the potential at infinity will be nearly 0. So we will get this, or the generalized term will be potential is equal to 1 upon 4 pi epsilon naught Q upon R. This will be the electric potential. Thank you.